Morning dear children, this video is for class 8 and the subject is science. We have begun with the chapter force and pressure and we are going to continue with the same. In the previous class we have discussed about pressure, that is pressure is the force acting on unit area of a surface and the SI unit of pressure is pascals. We also discussed that pressure is exerted by the liquids and gases too by understanding the concept by knowing certain examples. Then, is there any one example wherein both the pressure exerted by liquids as well as gases can be noticed? Yes, you can see this picture of the pressure cooker. So what happens in this working? That is, when the water in the pressure cooker starts boiling, it turns the water into water vapor. So the liquid turns to a water vapor and the steam is being generated. And this steam exerts an inert pressure in the pressure cooker and later the whistle is being blown out by the cooker and this shows the pressure exerted by the cooker. So this is one of the best example to notice both the pressures exerted by liquid and gases. Then what we are going to see in this picture now? So you're noticing that there's the earth and the atmosphere, that is the layers of atmosphere is being seen here. So noticing this picture, what is the next question arising in you all now? Yes, is there pressure exerted in atmosphere too? That we are going to study in this class today. So to start with that, let us understand this with this example. So you can see here, this is a cylinder standing on a surface and which includes the air particles inside it. So these air particles are exerting a pressure on this unit area and that is called to be as the atmospheric pressure. So the pressure exerted by air around us is known as atmospheric pressure. So not only the air inside the cylinder but even in the outwards also there is a pressure exerted on the walls from the outside. Yes, and there is even the gravitational pull downwards and the pressure is being exerted from the upwards and also from the sideways. So in overall this pressure from the cylinder is acting on this unit area and we term it to be as the atmospheric pressure. So in this layers of atmosphere when we are talking about, so in the previous class when we were studying about liquids in the bottle, I told we can divide the bottle into 4 to 5 layers and understand how the pressure is being exerted. So as higher the air particles go or the molecules in the air tend to move, the pressure, what happens to it? So as the troposphere is near to the earth, so it exerts a pressure which is more, and as the air the distribution of air becomes wider as it goes to the other layers, so the pressure exerted at the higher ends of the other layers will become lesser. So the pressure exerted near to the earth's layer is more compared to the pressure exerted at the topmost layers. So the nearing layers exert more pressure compared to the top layers. This is the how the pressure is being exerted in the atmosphere with the layers of the atmosphere. So what is this now? Yes, your guess is right. It is a rubber sucker. So you might have used it or noticed somewhere wherein it is being used. So whenever this rubber sucker is being pasted to a wall or on a surface, what happens? So when you immediately just go to paste it or put it onto a wall or any other surface, what happens? We can notice that there are some small air bubbles which will come out of this lining, and then this sucker completely sticks to the surface. So later it is very difficult to pull the sucker out. Why? Because there is an outward pressure which is being put onto this sucker, which will not allow you to pull the sucker out. And also the inside part of the sucker, that is the inside region in this sucker, is being completely filled with vacuum. That is, there is no air left inside that. So it is very difficult to pull the sucker out. Then how can it be pulled out? That is, the outward pressure, the applied pressure from the outside should become more. Then only this sucker can be re-pulled back. So where else we can notice this atmospheric pressure in our day-to-day life? So you can see, so this is the straw. Whenever you dip the straw into the glass, what happens? So when you start sucking it, so the atmospheric pressure which was inside the straw will get reduced when you suck it. So you can see little, whenever the straw, first when you are going to immerse it, it will be bit broad, and when you start sucking, it tends to become bit narrow. So by the observation also you can understand this application. So what was there when the straw was empty? That was, it was filled with air, that is the atmospheric pressure. So when you suck the juice or the liquid content, whatever you are taking, so what happens? That time this atmospheric pressure gets reduced. So not only it's acting on the straw only, but even on the containers too. So like that, this atmospheric pressure is being applied in our day-to-day life. One more example. So in the syringe, so whenever you pull the syringe, so first it will be empty, and even it will be having the air particles. So when you pull it, so the air pressure gets reduced, and what happens? The syringe is being filled with the liquid. And also there in the whatever medicine, a small tubes or the medicine containers which will be there, even in that also the atmospheric pressure is being tend to be in this direction. So these are some examples wherein we come across with the atmospheric pressure. Then do we also exert this atmospheric pressure? Because air is everywhere. So we have this question. Yes, we also come across this atmospheric pressure in our day-to-day life. But what's the thing that's making us to be so balanced? Why don't we fall down when this pressure is acting on us from the outside? Yes, we know that our body also contains certain gases inside us. So these gases also are exerting certain pressure from inside on our body, and even there is a outside pressure which is exerted on our body too. But as both are maintaining the equal balance with each other, we are unable to fall, but we are able to be stable and balance ourselves. That is the one thing which is also one of the best example to know about the atmospheric pressure in our daily life. So, what is this? So, this is the instrument called as barometer. So, this is being used to measure the atmospheric pressure. So, this will be a seal tube and the container of a mercury, and the atmospheric pressure is measured with this. So what is the name of the instrument? I am repeating it again. It is barometer. So, did you know in ancient times also whether this atmospheric pressure was noticed? Yes. Otto von Guericke, a German scientist of the 17th century, invented a pump to extract air out of a vessel. With the help of this pump, he demonstrated dramatically the force of the air pressure. He joined two hollow metallic hemispheres of 51 centimeter diameter each and pumped air out of them. Then he employed 8 horses on each hemisphere to pull them apart. So great is the force of air pressure that the hemispheres could not be pulled apart. So what's happening here? So the one horse is capable of pulling 109 kg of weight. So he's using here almost 16 horses, but also these horses are not able to pull this hemisphere. Why? Because the atmospheric pressure exerted around is more. Due to that, the horses are unable to pull it. So, if the hemisphere had to be pulled, then what should have happened in this case? That is, the pressure, the force exerted by the horses should be much more than the atmospheric pressure. Then only it would be able to notice that the horses would be able to pull the hemisphere. So, like this concept is being noticed from the 17th century itself. As the advancement happened, then these things were being very much noticed and being applied into our day-to-day life, and they are being defined with certain names and definitions now. So that was all about today. We have learned about the atmospheric pressure. So you need to read page number 140 and 141 to understand this concept more better. Thank you, children. Have a good day.